A large rectangular field along a river is to be enclosed by 1,200 meters of fence. It is not necessary to build a fence along the river. What dimensions will give the maximum area? What is the maximum area? For this question, it's easiest to draw a diagram to represent the variable. Here we have the river, and we have to construct a rectangular region beside that river. We can introduce x as the width of that rectangle. Now, because we have a total of 1,200 meters of fence, the length of that rectangle will be 1,200 minus 2x. We can then express the area that is enclosed as a function of x. We'll use the fact that area of a rectangle is length times width. We can then find the vertex of the resulting quadratic function. We can either do this by completing the square or by simply finding the zeros of the corresponding graph. Note that the x value of the vertex will be midway between those zeros. The x value of the vertex will give the width corresponding to the maximum area, and the y value of the vertex actually gives the maximum area. In this question, note that the area, which is equal to length times width, is going to be 1,200 minus x, or minus 2x, which is the length, times x, which is the width. If we expand this out, we get a equals negative 2x squared plus 1,200x. Here we're going to complete the square, so we will factor a negative 2 out of the negative 2x squared plus 1,200x. This gives negative 2 times x squared minus 600x. We then have to add something that completes the square. To do this, we divide negative 600 by 2, giving negative 300, and then square that. Negative 300 squared gives 90,000. Note that this 90,000 is being multiplied by the negative 2 that we had factored out. That means that we're actually subtracting 180,000. To compensate for this, outside the brackets, we add 180,000. We can then express it in vertex form by changing what's inside the brackets to a perfect square. This will correspond then to a equals negative 2 times x minus 300 all squared. Note the minus 300 comes from the negative 600 divided by 2. And then plus 180,000. In this case, the dimensions, the x value is going to be 300. Note that's the x value of the vertex. That means that 1,200 minus 2x will be 1,200 minus 600, which is 600. So the dimensions are 300 meters by 600 meters. The maximum area is the y-coordinate of the vertex. That corresponds to 180,000. Note you could also simply multiply 300 times 600, and that would also give you 180,000. The other way you could do this is by figuring out the zeros. If we have the area equals x times 1,200 minus 2x, the zeros, which correspond to the x-intercepts of the graph, correspond to 0 and 600. This means that the vertex is right in between those two zeros at an x value of 300. We can then simply plug in x equals 300 into the above equation. A equals 300 times 1,200 minus 2 times 300. This gives a value of A, the area, again, of 180,000. We then get the exact same results. The dimensions of 300 meters by 600 meters, and a maximum area of 180,000 square meters.